Let us move on to the next question. This question is from Irodov, and let us see what this question is. There are two positive charges located at points radius vectors r1 and r2. The two q1 and q2 located at position vectors r1 and r2. Find a negative charge q3. Okay, basically what he's saying is we need to find a q3 charge. What is the magnitude of this q3 and where should it be placed so that the net force on all these three charges must be equal to 0. Let us see different possibilities. Okay, we see q1 and q2 are here. Now where shall we place q3? See, if we know where to place q3, then we'll start our calculations. Okay, so first I'll say let us place our q3 here. Okay, if I place my q3 here, see this charge, there is a repulsive force due to this and there is an attractive force due to this. Okay, so if I place it anywhere here or anywhere here, will this be in equilibrium? This will not be in equilibrium. Okay, he said all three charges must be in equilibrium. We are finding one charge that is not in equilibrium. So keeping this charge anywhere here or anywhere here is not going to satisfy. Now let us see another possibility. Suppose we keep the negative charge on the line joining these two charges. So there are again two parts. I could keep it outside outside this side or that side, or I could keep it between the charges. Let us see for the possibility if we keep it outside. So if I keep this charge outside, due to this there is an attractive force, due to this also there is an attractive force. Will this charge be in equilibrium? It will not be in equilibrium. So again, this possibility is eliminated. All the space possibility is eliminated. This is eliminated and this is also eliminated. We are only left with one possibility, that is in between the charges. Okay. So let us say we place this negative charge in between the charges. Okay. You see on this charge, there is a repulsion due to this and there is an attraction due to this. Could be in equilibrium if the both forces are equal. Here also the same thing. On this negative charge, there is a attractive here and attractive here. There is a possibility that all three charges could be in equilibrium if the setup is like this. Okay. So let us proceed in calculating what is this charge and what is the position vector of this charge. Okay. So we have q1, q2, q3. We have taken this as x and r is the distance between the charges. This is r minus x. The position vector of this is r1 bar, r2 bar and r bar. And we need to find this r bar and the magnitude of q3. Okay. So first, the force on this is 0. The net force on this is 0. So what shall we write? Tell me. K q1 q3 divided by, so force between, this separation is x, okay, x square equal to this force due to this, q1 q2 divided by r square. Okay, I have cancelled out the k and k. Next let us write for this. This is also an equilibrium, right? So on this, the force due to this is what? q2 q3 divided by r minus x whole square equal to, so due to this, q1 q2 divided by r square. Okay, now let us just simplify this. So I can cancel out q1 here. I'll get root q3r equal to root q2 into x. And here I can cancel out q2. I'll get root q3 into r equal to root q1 into r minus x. Okay. So see, root q3r, we can equate this and this. So what will we get? Tell me. I can equate root q2x equal to root q1 into r minus x. Okay. So I can just, so x will be what? Tell me. I can bring this here. So x will be equal to Q2, just a minute. So this will be the value of x. We do not want x, we need r bar, okay? But we have found one part of this. Now we have got x. We can just keep this x here and we can get the value of Q3 from here. Okay. So if I keep x here, what will I get? Root Q3R equal to under root Q2 into x is what? Root Q1R divided by root Q1 plus under root Q2. You can cancel out this RR here and we'll get Q3 equal to, I'll just square this, Q1 Q2 divided by root Q1 plus root Q2 the whole square. Now another important thing is this Q3 is a negative charge. So we just need to put a minus here. So this will be the value of Q3. Next we need to find R bar. So what is R bar, tell me? R bar is nothing but R1 bar minus X bar. We are taking X bar this side. Okay. So R bar equal to R1 bar minus X. Okay. So R bar equal to, see, we have this X. Okay. We have the magnitude of X. We need the vector form of X. So we can just write this as root Q1 divided by root Q1 plus root Q2. What is this R, tell me? This vector R is nothing but R1 bar minus R2 bar. So in this place, I'll just write this as R1 bar minus R2. Okay. Now I'll just take this side, root Q1 R1 bar and root Q1 R1 bar will get cancelled. So we'll get R bar equal to root Q2 R1 bar plus root Q1 R2 bar divided by root Q1 plus root Q2. Okay. So finally, we need to place this Q3 negative charge of this magnitude at this position vector so that the force on all three become 0.